Okay, let's take a look at the intermediate value theorem. It says, suppose a polynomial function called p of x has real number coefficients. If p of a and p of b have opposite signs, then the function has a real zero somewhere between a and b. So a is going to be an x value and so is b. Let's take a look at this example. Determine if the function f of x equals x cubed plus 4x squared plus 7x minus 9 has a real zero between 0 and 2. So our two values are going to be 0 and 2 that we'll use for a and b. So if we need to calculate p of a, in this function we're talking about f of 0. That's the first value that we're given. So we'll evaluate our function with x equaling 0. So let's go 0 cubed plus 4 times 0 squared plus 7 times 0 minus 9. Okay, all that simplifies to 9. So that's a negative number. We're looking to see if we're going to end up with a positive when we evaluate p of b. Okay, so for our function f here, b is going to be this 2. So we'll do f of 2. Okay, 2 cubed plus 4 times 2 squared plus 7 times 2 minus 9. Okay, that's going to give us 8 plus 2 squared is 4 times 4, which is 16, plus 7 times 2 is 14, minus 9. Okay, that's 38 minus 9, which is going to give us 29. Okay, so we had negative 9 the first time. We ended up with positive 29 when we evaluated at the second x value. These are opposite signs. Just like the theorem states. So since they have opposite signs, all we can conclude is that a 0 exists between those two numbers, 0 and 2. Okay, let's take a look at what the graph is going to look like for this. So let's see, go to your calculator, go to the y equals screen. Okay, we'll type the function in. It's going to be x to the third. Oops, go back and delete one of these x's. Okay, x to the third plus 4x squared plus 7x and then minus 9. Okay. Now your calculator may already be set up in a standard window. I'm going to go do a zoom 6 just to make sure. Zoom 6 gives it that standard negative 10 to 10 window. Okay, although we don't have a clear idea of what the graph is doing overall, we do see that there is a 0 right here, right around 1, and that's definitely between our two values that they gave us, 0 and 2. Okay, so what we can do to find the exact value is press the second key followed by the trace to get to the calculate menu. Notice option 2 is 0, so we'll press 2 to select that option. And we'll follow the commands. It's going to ask us for the left boundary point, and all we need to do is make sure that the cursor is to the left of our 0. Right now our cursor is down here. It is to the left. I'm going to scoot it up just a little bit. Okay, it's still to the left, so that's okay. I'm going to press enter, and then it wants to know the right bound. So I'm going to make sure I go to the right of this 0 that we're trying to find. Okay, that is I think that's to the right, but let's go a couple more spaces just to make sure. That's definitely past the line. So let's go ahead and press enter. That looks like a good spot. And then it'll always ask for a guess. If you want to get closer to the point, you can. The calculator will do the work either way. And here's our 0. X equals about 0.821. And the y value is 0. So the coordinate is 0.8210. But as far as the 0 is concerned, it's about 0.821. Okay. And down here on the graph, we've got 0 was one of our points in question. 2 was the other point, and from the graph that we saw, our line came up right about there, and this point is the coordinate 0.8210.